with telescope stuff.
Right, right. I used to bring him a lot of fresh
Well,
bread.
gentlemen, I hate to interrupt you, but we, I think, are on YouTube and we're broadcasting live, telecasting. Hello, stargazers everywhere, astro freaks. My name's Ron Heron. I'm the proud host of the SBAU Astro Hour. It's a weekly online vlog or blog or podcast, whatever you want to call it, for South Central California Coast longtime astrophysics and telescope club, the Santa Barbara Astronomical Unit. I call it 93 million miles of fun in the sun, although I think we're a little further than that right now. It's not exactly circular orbit.
No, we're closest in summertime. Oh no,
Yep.
you're right. We're farthest. Never mind. I'll shut up.
Oh, it's okay. I
Well,
know I know my talking points from the man to the left of me on the screen. He knows. And we do this from our home observatories or computer dens every Monday morning, 11 to noon, with YouTube viewers all over the place able to ask questions or make comments down below, like my old friend, by golly, in Michigan, Sam Gordon called me this morning. It's been years. He's watching us, going to spread the word in the Midwest. SBAU is headquartered at the Santa Barbara Museum of Natural History, which supports us. Check us out on sbau.org, please. And then come join us at our first Friday of the month general meetings, which is going to be a potluck this Friday. Instead, 5 o'clock, 2 hours earlier till 8. And we'll be over there across the creek at the museum. And doggone if we're not having nothing but sunshine for the whole meal. And our second Saturday of the month star parties are always well attended at the museum in the dark. And at any one of the countless other outreach events that the Astro Unit does. We meet at hotels and schools and parks and everything. This week, we're going to cover these topics, hopefully. Nailing down the location of the planets in the night sky, new moon, summer triangle, Milky Way gets a little milkier, perhaps. Come check on some stars. We're going to do that. Antares, Vega, Omega, Deneb. Omega's first and second, and one of two septupular systems, 7 stars orbiting. You can believe that? And we're going to delve deep into the Cygnus Swan constellation, check out its NGCs and nebulae. Speaking of nebula, North America has one, and there's also a galaxy named after the 4th of July. And Andromeda is brightening up a little bit, M31, speaking of galaxies. Also counting down for a probable supernova blast this fall,
No.
September.
No.
Last time it blew, it was my birthday, and I had 3 wise men visit my cradle. It was awful. Asteroid, let's see, what do we got? Asteroid 2024 MK. I'm not sure if we're going to talk about that. Well, let me introduce you to the guys, and we'll find out where we're going from here. Have some silliness. The captain of the starship is President Jerry Wilson, 7 years at the control panel there. He's married to the beautiful Pat Forgy and a beloved man. Chuck McPartland is the captain of outreach. My God, the man knows his stuff, gets us everywhere. And I don't know, he's indefatigable with his instrument. He's married to Pat McPartland, our merchandise manager and our brand new treasurer. We have Tom Whittemore, who is editor of our monthly newsletter, retired from Westmont College, married to Maureen, and a good guy, knows his stuff. Bruce Murdoch is on board again, longtime supporter and telescope enthusiast. And then there's Tim Crawford. Bruce is married to Bonnie. Tim is married to Karen. And Tim, I think, is featured in a picture as a younger man in our newsletter that was just sent to all of us by Tom. It was interesting.
About a week ago. Come on, Ron.
That's all right. We're aging gracefully, all of us. What we'd like to do is start our weekly program, Sam, and everybody else watching, with a few laughs using President Jerry's forwarded silly science cartoons, either laughs or, in this case, thought provokers. You think you're bored? Sir Isaac Newton invented calculus during his plague. You have any idea how bored you must be to invent calculus? Jerry Orbison, plague. I think, what, Jerry, you solved the cancer cure. You came up with something. It just hasn't been exposed yet. Expand this a little bit. This is another installment of Science Stand-Up. Kentucky Fried Chicken, KFC, has just asked this scientist to edit the chicken genome. They want something a little crisper. You got to know what CRISPR is. It has to do with genes.
It's the process by which you alter genes. You take things out, you put things in. You
Yeah,
basically
right.
rewrite the gene.
And if they can get the genome of the chicken right, they're going to have a third leg, and it'll be an extra drumstick if they can get three-legged chickens out. All right, we've just discovered, this is from before, that Lego hands are the perfect size for making sure your phone charger doesn't fall off your desk. You look carefully, it's okay. Maybe that's how they sell them. Now, here's the one that Tom Totten, who's not with us on the screen, our webmaster, blew him away, and I sort of figured it might have something to do with a lot, but with ions. Apparently, that's the L ion, which is a male cat.
Yeah,
And-
if this is L, then this is L ion.
which means what? An extra
Plus charge
neutron?
means missing an electron.
Missing an electron?
Yep.
Yeah.
Makes it
Okay.
positive. That's what the plus sign is.
It's a science joke.
I know that, but how can you have an atom at all without an electron? Hydrogen only has one.
And a
Because it's
proton is a
ionized.
hydrogen nucleus without the electron.
Yeah.
It's an ion. It's an ion. It's ionized.
Proton.
So it's a proton and a neutron, or no neutrons in
No
hydrogen?
neutron, just a proton.
Okay, interesting. L plus. All right. Got
Deuterium
it.
is hydrogen with a proton. or a
The
neutron.
things we learn on this program, folks, amazing. Lie on.
Okay.
I saw this.
Prior to the universe becoming transparent, the everything was just a morass of protons and electrons, and they weren't assembled into atoms yet.
Well, atoms to me are protons and electrons. I don't understand how you can have an atom without that. Anyway, here's the
Neutrons
notice.
too.
If you notice this notice, it was posted, notice down the street from me. Notice, if you notice this notice, you'll notice that this notice is not worth noticing. Dot, 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 dot. If you're ready for the next tornado, watch out. This lady is ready. With her,
yeah.
She's wearing the ruby
Yeah.
slippers.
yeah, Toto, get ready for a trip. It has nothing to do with drugs. This one's going to have to be expanded. Sleeping positions of different professionals. I like this one. Can you enlarge it at all? Here's how different pros. The teacher sleeps on their back.
Oh yeah.
Lawyer sleeps on his left side. The engineer sleeps lying down, and the astrophotographer sleeps in
Doesn't
dark
sleep.
matter.
He
Yeah, it
doesn't sleep at all.
doesn't sleep
Yeah.
outside, occulting in his yard at 2 o'clock in the morning. I got it. Okay, this one I didn't see.
No,
Wait
this
a
one
minute.
came in late last night.
All right, you didn't get it to us. There's a couple of aliens living in a cave on a foreign planet, and what's it say inside the little balloon? Who's talking to them? Is this a
Oh,
science
it's just
on
blah,
Earth?
blah, 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 blah.
Oh,
Someone on Earth is seeing that there's water on Mars.
oh,
The
okay.
husband's yelling at his wife for throwing the water out.
Don't throw the water out. It's buried on Mars if we got any left at all. There we are in the distance. That's a good one. I don't know where you get these. Yeah, here's the early bird that gets the worm having a conversation with his meal. So you just dig through the soil, consume nutrients from decaying organic matter, and you know what? That actually makes a lot of sense. What the hell am I going to do? Eating you
So this
for?
is the early word gets the worm, but gets here means understands.
Okay, got it. All right. None of us did, but I do now. Okay, we're off and running with the night sky, first of all, and other great things happening. Did you want to add quickly about the passing asteroid? It was pretty good size, wasn't it?
In the Osaka's office, right?
It was like 600 feet across, something like that, 300 or 600. But it was early in the morning on the day Jerry sent out his email.
Yeah.
The
Yeah.
next, that night.
And it was called 2024 MK.
Yeah.
Well,
And it went between us and the moon
yeah.
Yeah.
Sunday morning or
I
Saturday.
think it was
I forget
Saturday
which
morning.
day it was.
Saturday morning. Okay.
Yeah.
Would have made a
That's-
splash.
No, it was
night.
low in the south. It went through Sagittarius and Scorpius at like between midnight and 4 a.m. And it would have
That
been barely visible in binoculars.
That
Well-
information you sent out, Chuck, about how to find it and where to look.
Yeah.
Boy, I looked at all that and I was saying, I don't get that at all. Is that what you do for asteroid occultation too?
Similar, yeah. I mean, that was the right ascension and declination of where it was going to be at a certain time, so you could just get your scope pointed at it.
Is that the nasty one called Apophis that's coming back
No.
in 29?
No.
Isn't there one that maybe get altered and it's
That's
direction.
coming attractions.
And that's been ruled out. But it will be naked eye visible when it goes over.
Friday night, we were up at East Camino Cielo, and we got a real treat. There was just a bright object that came streaking across the sky, and it lasted, from we didn't see it where it first came in, but it was, overhead. If I look at a clock face, say it was 11 o'clock, and it went all the way across the sky and disappeared on the other side.
That was a deorbiting Starlink.
Yeah, that's what I found out. We thought, it lasted way too long to be a meteor.
And
And
there's 150 more of them that they're going to deorbit like that.
okay.
Well, Mr. President, before we start the main menu, any updates on the 2 stranded astronauts in the space station? Are they coming
Well,
back?
technically, they're not stranded.
Oh, they're not.
Just lounging around.
Yeah.
They want to test the. I sent you a blurb.
Yes, you did. Horizon
Something on
something
it
or
that
other?
really got at the right tone for this. All the problems that they're having are in the I forget what it's called, but it's the instrument unit that's under the reentry package.
The service module.
Sir, thank you. That's good. And then they're going to jettison that before they come back. So this is their only chance to test it and debug it, figure out what went wrong. So they're staying up there while they run all sorts of tests on it. So far, the length of their stay is not adversely affecting their chances of getting back. So they're not really stranded there. They're just taking advantage of an engineering opportunity.
Well, I'm noting that I would think that helium is better to leak into space than rocket fuel, wouldn't you think?
That doesn't matter.
It's why
When it's going to space, it's gone.
It's why they use helium, Ron, because if they use hypergolics or some other rocket fuel type stuff near the ISS, they leave a cloud of contamination, and the helium is, less contamination, and it goes away quicker.
I wonder if that helium is used, or those retro rockets in coming in through the atmosphere and keeping them from burning up.
Probably some of the maneuver stuff, but no, not for the retro rockets, I don't
Not
think.
for the retro.
They're not going to be powerful enough.
All right, let's go to the night sky, shall we, gentlemen? See what we're looking at. If we can't lock in on an incoming asteroid, can't imagine tracking one of those. Here we go. Our concave horizon again.
Our wide angle lens.
Exactly.
If I move the horizon up in the frame, it'll flatten out. So
Nothing
I
wrong
put
with
it down
this.
to get it out of the way.
Feel like a fish.
So this is yeah. Okay. So this is the west. It's right after sunset. You can see the sun here is just setting, and the sky is not usually this dark. This is my planetarium program. So but it demonstrates how Venus and Mercury are now in the evening sky, but they're so close to the sun that it's really difficult to get a good observation of them.
Can I explain something I'm unclear about, and I don't know why I should know this? We get a different layout of stars and planets in the night sky than we do during daytime when we can't see them, when we're turned toward the sun, right? Is there ever a time when some of them disappear because they're in the daylight?
Yeah.
That does happen.
Yeah.
Well, in effect, that's what's happening right now with Venus and Mercury.
Yeah.
I know, but they're all there, aren't they? Shouldn't some of them be
the sun is not here. If this were several hours earlier, the sun would be up here about to set, and you would see blue sky and you wouldn't see any stars or planets.
Well, I sent you a picture I took of Venus and Mercury from my deck a couple of years ago.
Yeah.
And it was right after it was dusk.
Okay.
Yeah,
Well,
but it was also the sun was not in the sky.
Oh, no.
Yeah. So
I waited
Barrett's
till
question was,
sunset.
why don't we see the planets when the sun's up?
Oh yeah, sun's too bright.
Yeah, it's scattered. The atmosphere scatters all the blue end of the spectrum, so the sky glows blue.
Yeah.
Ron, were you wondering whether planets go directly behind the sun, which does happen on occasion?
Well, here's what I'm thinking. Right at this moment, there is a sky we can't see that's in the dark because we're sitting now in daytime. Are the planets in that sky that we can't see, and yet we're going to see them tonight?
Yeah.
We are. They're going to stay there, and we're going to turn. I go, okay, I understand.
Well, they stay there and we turn. Yeah.
Got it. All right. I got it.
Okay.
I think that thing below to the left of Venus, I think that's the Eskimo Nebula.
Right there.
Yeah.
Could be. It's a planetary nebula. That's the symbol for
No,
it.
that's the Eskimo, because Wasat that's my star hop. I go towards the head of Gemini and just out with a little bit of that's perfect for where the Eskimo is.
Uh-huh.
Try that tonight.
I guess we can't call it the Eskimo anymore.
Oh, yeah, clown
What do
face.
we-
Clown
It's,
face.
it's what?
The Clown Face Nebula.
Oh, the clown. Hmm.
But what are the
Well-
what are the constellations we are looking at here? Can you make sense?
These are evenings things. There's of course Leo. Funky drawing of Leo. There's Hydra.
Looks like a stick
And up
dog.
here is Ursa Major.
right?
So
But
we're covering a good fair piece of sky up here.
Yeah, yeah.
The Ursa Major is coming down here to swing around. It's a constellation that's circumpolar is referred to, and at our latitude, it never actually goes below the horizon, unless you have, assuming you have a flat horizon. If you have mountains, it'll go behind there. So Leo Minor,
And then Gemini below.
yeah, Gemini down here with the twins Castor and Pollux. There's
if you were up
here.
if you had your instrument above the Arctic Circle up in the North Pole, all you'd see would be a turning carousel, wouldn't you? Day and night.
Straight
Yeah.
up, yeah.
And a lot of these things you couldn't see because they would be below your horizon.
Yeah.
Oh, okay.
And
Yeah,
the sun
right.
would just be skimming around your horizon, more or less.
Yeah, right.
Well, Australia has a whole different sky to look at, don't they?
Same sky, but upside down and a different part of it.
Okay, got it.
They see all the south and a little bit of the north.
Wow.
So this is the morning sky. This is our planet rundown, and this contains the rest of the planets. There's Jupiter, Uranus, Mars, Neptune, and Saturn, all lined up along the ecliptic. And down here past the sun, it will pass the sun and then way down there get to Venus and Mercury. So these are the summer and fall constellations starting to put in an appearance for us. Perseus, Taurus the Bull, and Cetus, Pisces, there it is.
Mhm.
Kind of winter and autumn stuff.
Yeah, winter and autumn.
And I saw
It's big,
Jupiter come up at 4:30 this morning.
What did you say at 4:30, Tom?
Jupiter, I saw it come up real bright in the north.
Oh,
down
North.
here. Yeah. So
what's
this is at 5 a.m.
what's
and-
the cutoff magnitude for seeing M5 or M4?
6.
Oh, okay.
And there's the at this time there's the almost new moon.
There's a little crescent this morning.
Yeah, right there next to Jupiter. Actually, this is tomorrow morning, I think.
Aha.
July 3rd. It's Wednesday, it's Wednesday morning.
So we have the last of the old moon dying.
Oh,
Okay.
excuse me. Keep talking. I gotta.
Uh-oh. Something happens every so often, gentlemen. Chuck, you want to tell us where you're going to be with your telescopes this week?
Well, for the 4th of July, we'll have a star party at Bakara.
All right, that's Thursday.
That's Thursday. And then Friday's a potluck. Saturday is Kachuma. And I think everybody's going to have to go 101, 246 if they want to go to that because it's closed.
It's
San Marcos Road is closed and 154 is closed from Painted Cave. So
Right.
we got to go around the long way. And then Tuesday, the second Tuesday of every month is Telescope Tuesday at Camino Real Marketplace. Thursday, the 11th, is Carpinteria State Beach. And Friday, the 12th, is again El Capitan State Beach, kind of taking the place of Refugio until Refugio is fixed. And
Okay.
then the 13th is second Saturday is our normal Museum of Natural History star party night.
Okay, bring something delicious and a lot of it Friday night, and I'll eat it.
Pat's going to do lasagna.
Oh, okay. I'm bringing chicken.
Okay, I'm back.
All
Joe
right.
Doyle's going to do tri-tip.
You're doing Mexican, aren't you, Mr. President? You got
Yeah, I'm gonna bring chicken enchiladas.
there you go.
Now,
If I can get there, I'm bringing Costco cookies.
Now I know I'm going. Okay.
Yeah.
what
good.
about the standard amateur astronomy cookie, the Oreo?
The Oreos? Yeah, those are standards.
Maybe Tom Totten will bring that. He's our cookie man.
Uh-huh.
All right. Where are
So
we?
this is the summer triangle coming up. Deneb, Vega, and Altair down there make a triangle. And the base of the triangle is roughly lined up now along the plane of the galaxy. So the Milky Way is going right along here. Very rich region of sky. This is just before midnight. This is 11 o'clock on July 3rd, I picked. A lot of stuff down in here to see. This is the core of the galaxy. It's coming out of the teapot asterism down here. And the focus of the Sky and Telescope articles I looked at for today's talk or APOP pod is the region of Cygnus. This is a very rich region with a lot of nebula in it. One is shown right there, sort of in red in this planetarium program. And that's the region of the North American and Pelican Nebula.
Gentlemen, I've asked this question before. Any three stars, unless they're in a straight line, can make a triangle. Who decides? Who made the decision? These three are the summer triangle.
Nobody. These are not, almost everything we talk about here in asterisms are just popular ways of talking among amateurs largely. Astronomers don't sit around and talk about the summer triangle. It's us that
somebody came up with it. I mean, we're all talking about the same triangle.
Yeah, just groups of amateurs that are out there showing the sky to their neighbors and stuff. They started naming these things, and the names shift and change, although the summer triangle probably is going to stay that way, but different names for things like we'll see later, the Firecracker Galaxy, or I think that's what it's called.
Fireworks, yeah.
Fireworks Galaxy, yeah. That's a popular name. That is not an astronomically recognized official name.
Oh.
Also
And these
depends what
change.
country you're in.
Yeah.
Well,
The name changes.
can Australia see our triangle?
Depends where you are in Australia.
Do
Yeah.
they have their own triangle, you suppose?
There is a Southern Triangle constellation and a Triangulum constellation, but yeah.
Yeah.
It's a whole constellation with three just three.
No. Well, Triangulum sort of is just three bright stars, but this is three really bright stars.
Well, there's a mini galaxy in there called Triangulum, isn't there?
Yeah.
Yeah, right behind me.
The Triangulum Galaxy.
Yeah, that's the M33 Triangulum Galaxy.
Keeping it simple.
That's not in this picture, though.
Right.
So this is the core of the galaxy coming up. The start of the good summer constellations in Scorpius here, right around to there. So about 11 o'clock at night, we'll see Scorpius this way. And there's three stars have been identified up here: Nu Scorpius, Beta Scorpius, and Omega Scorpius. And these stars are each double stars.
Or multiples, anyway.
Multiple, yeah, good.
But we only see them as one. Isn't that interesting?
No, you
Get a telescope on them.
Yeah, you put a telescope on them, you'll see them as double or more. So, and right here, if you can center on this, a lot of people have trouble seeing color in stars, even with a telescope. For example, my wife cannot see any as a star as anything but brilliant white. And so I put my 12-inch telescope on Antares one time, which was a blazing reddish orange. And she says, well, maybe I see a warm tint to it. But that's the closest she's come to seeing color in stars. And that's not unusual. A lot of people are like that. Because color vision in humans is stimulated by brightness. It has to be colorful and bright for you to really perceive color.
Well, are all the colors represented in stars? Or is there a color that you don't see in star? Are there any
Green.
green ones out there?
Green is the one you don't tend to see.
Why is that, I wonder?
Our sun is yellow-green, and we have sort of evolved to perceive that as white. So that's part of it.
Yeah.
Hmm.
Now the Antares around here is a bright orange star, and it also has a companion. I believe this is the one.
Yes.
And people look at that companion. It's a very close to Antares, but you can see it in a telescope under good conditions. And that star, to some people, looks green, but it's an optical illusion. There are no, as Chuck says, there are no green stars in the sky. It's just
Really?
a contrast to Antares.
Isn't green sort of the dividing line between infrared and ultraviolet?
No, green's right in the middle of the visible.
Well, that's what I mean. Well, one end is ultraviolet, the other end is infrared, and there's green in the middle. It's my favorite color, incidentally.
Okay, good.
Nature's favorite color.
There are stars there are double stars that also people perceive one as green because the other one is intensely red. It's kind of a
There
Like-
was a
Yeah,
like Jerry said, it's an optical illusion, really.
there was a test
Almost
when I was in the dental lab business. Somebody did a test where they drew a circle on a white piece of paper, and then right next to it they drew a circle and they colored it red, and they had you stare at the red circle
Mhm.
for about a half a minute, and then you look at the one that's just the circle with white, and the color you see in the circle that's white is green. And
Yeah.
it's because
It's a complementary
it's
color.
the complement of the color, and that's why the green is showing, because our eyes, it'll go straight to the complement.
Yeah, if you're colorblind, how do you handle traffic lights?
It's
Yeah.
the position. They standardized the position of red, yellow, and green.
Yep.
Is that right?
Yeah.
Yeah, well, as Kermit used to say, it ain't easy being green. All right, where are we now?
This is a picture of Beta Scorpius, which we just looked at. It's also called Grapheus.
Mm.
This is a photograph through a, let's see, is this a,
8
this
inches.
is a
sketch, yeah.
pencil sketch, yeah. And it is, and this picture is actually an image, I think.
Mhm.
No, there's no exposure time. So this is all pencil sketches,
Oh,
highly magnified and at low power. So it's a resolvable double star.
Mhm.
Oh, nice.
It's easy
Well,
to.
we'll have to try that one, Tom.
Oh,
Yeah,
yeah.
the separation is 12.6 arc seconds.
You can drive a truck through that.
Yeah. A skinny truck, but yeah.
do most, if not all, of the constellations have a primary, which would be the alpha, and a secondary, which would be the beta, and then there's a gamma star? I haven't.
Yeah.
I keep seeing those and wondering what that means.
That's the way they generally did it, but it's not a hard and fast rule. Because in some constellations, the alpha star is not the brightest; it's just kind of the most famous. So, but initially, it was intended to be in order of brightness.
Well, is this star we're looking at part of its pinchers or its tail, or
It's,
The head.
it's up in the head.
it's up in the head? Okay.
Here's Scorpius. There's the head up here, and these are the pinchers.
Aha.
Now, my two favorite stars used to be the pinchers, I guess.
Yeah.
So they came out here, but they cut them off and put them in Libra.
Stolen by the Romans.
Yeah.
What if there's places in the world that don't have scorpions and they have no idea what the hell that is in the
Yeah.
sky?
Yeah. In Polynesia, that's the fishhook of Maui, if you've ever seen Moana.
Oh, they have a different connotation up there. Okay, got it.
Now these are nicely separated double star. These are the omega stars, omega 1 and omega 2. And that is shown here. There's omega 1 and a 2. These are the omega double stars. That's probably, at this position, that's probably a naked eye double.
Hmm.
So, and this is a photograph.
Mhm.
an amateur photograph. Now the next one, new Scorpii
A septupular, huh?
is what?
Is this the 7
Yeah, this is the 7.
septupular or
So there's this is a schematic. It's quite a complicated system. There's 1, 2, 3, 4, 5, 6, 7. So the
stars?
center of mass of this collection, it has this orbit around the center, or this center of mass here has this orbit around the common center of the whole thing. It's a group grope here.
Yeah.
The 4 on the left orbiting along opposite the 3 on the right, a common center.
There's 2 here that orbit a common center,
Oh, okay.
and that common center is paired with this one. The common center of this triplet is paired with this as a double, gravitational double. And the common center of this one and this one orbit each other. And this one and the common center of this one orbits like this, and these 2 orbit this way.
God, imagine
So-
living on an exoplanet on one of those.
Yeah.
Figuring out the winter solstice and the summer solstice on this is going to be a nightmare.
I'll bet.
So
now,
that's,
Why wouldn't this qualify as a small star cluster?
I don't know. They are all gravitationally connected. So it's probably like the phrase in the definition of a planet where it has to clear its own orbit, so to speak. So it's the mechanics of what goes on close up that helps define it. This is one of 2 systems known in the sky that are 7 stars.
And there's it was originally a short novella by Isaac Asimov, but it's been expanded with some other authors called Nightfall. And it's about a planet orbiting one star in a system like this. And they never have a dark sky except for once every like 50,000 years when they all get occulted by the, they're all on the same side of the planet. And so night falls around the planet.
Mhm.
And they
And
go crazy.
and the entire civilization goes crazy because they've never been in darkness.
Yeah,
Yeah,
that's
I
also,
read that when I was a kid. There's also a movie that's based on a similar effect.
there's a radio show on old time radio on Sirius, and that episode's in there.
Oh, okay.
Well, there's a Star Wars segment that has 2 suns in the sky. One,
Yeah, it's Tatooine.
interesting. Wow. What's the other 7?
This is something else, Sherry. That's something else.
Yeah,
Do you know what the other 7 star system is?
no, but we can look it up.
Thought you mentioned
So
it.
this is a table reference of the graphic we just worked our way through.
Oh,
And
wow.
these things go around each other in 5.5 days, AA and B, AB. The center of mass of this one and this one rotates every 5.7 years.
Oh, wow.
The center of mass of this one and this one, it just has a 1.3 second separation. So you can see this. 41 second separation. This is going to be another drive a truck between them things. 2 second separation. And they're far enough apart that they can't, I guess they haven't observed them long enough to get a time for them yet. But 2 second separations. Orbit here is unknown. But these are all pretty much, especially these in here, these are all observable as separate stars in our small telescopes.
And Jerry, in your write-up, you do have the other 7-star system is AR Cassiopeia.
Oh, okay. Thank you.
But imagine if every one of those 7 stars had a whole set of planets like our solar system. They might even interact.
Yeah.
Planets of one star with another. They get close enough, out.
Yeah.
Their Oort clouds, their Kuiper belts, all intertwined.
Well, they would have been disrupted by that, but yeah.
Okay.
Our planet, if our planet were somehow involved in a star system like that, we would not be there. There's no stability over a long period of time for life to evolve.
We wouldn't be in that Isaac Asimov novel. What's the name of it? I'm going to read it.
It's called Nightfall.
Nightfall. Okay. Sounded like him. Produced
There was a
body of
science
work.
fiction movie based on this same idea called Pitch Black.
Oh,
And they were on a planet, and they had these monsters that lived underground because they couldn't stand the UV content of the daylight suns. And so they would, when on the rare event when that planet got dark, these things would come out.
Mm.
Okay,
Do they live in coffins?
what's that?
Do they live in coffins?
No, they're not that kind of thing. They come out in the dark.
they came out of
So this is a sketch of Cygnus showing the North American nebula here, the Veil Nebula. These are all features, famous features, and easily visible for amateur scopes in there. Matter of fact, you can get the entire loop of the Vela, which is a supernova remnant. You can get that in a single field of view of some of our smaller scopes with a wide field of view.
But you need a really dark sky for that one.
You do.
Go up to East Cielo.
O3 filter will help.
Yeah.
And then this is, of course, the Summer Triangle again with Altair down there. This is M29 up here, up this star, and this is the Crescent Nebula, and this is just a big field of nebulosity over here.
But your 4th of July is not in this?
No, we're not there yet.
Okay, gotcha.
This shows the North American Nebula. See, it looks like the Gulf of Mexico, Florida. This is Florida in about 50 years when most of it's underwater. This is the Gulf of Mexico, or the Gulf of Mexico here. This is Mexico. There's Hudson's Bay up there.
Oh,
This photograph shows it, a lot of it filled in because it's overexposed quite a bit.
stretching it a lot there,
This shows the Pelican Nebula. See, there's the pelican's head and beak
right?
and his wings and stuff.
Had to be some heavy drugs involved with naming these things. You guys,
Hey, Jerry, the California Nebula is not the left side of that image. It's yet
No.
another.
No,
Okay.
it's in Perseus.
Yeah.
Okay, good.
And it stands alone. It's a lump of nebula that's illuminated red, but it's not part of a bigger accumulation that's illuminated.
Okay, thank you.
Okay.
wonder about the 2 signatures at the bottom of that picture. Of course, it's too late now.
That's the photographers probably.
Yeah.
Is that what? Okay. There they are. Oh, I know them well.
Yeah.
Smaller
So-
than some lady.
Those aren't space nebula. Sorry. Okay, Cygnus.
Oops.
We're going to go out to the Independence Day
Not yet.
galaxy.
Not
Oh, we're
yet.
still not.
Now
Okay.
this is an area of the Milky Way that is very dense with things. This is a NGC 6989 is a open cluster. It's very obscure to me that there's this cluster here that stands out from any other grouping of stars, but that's the official NGC 6989.
And those are stars that have been found to be sort of at the same distance, so they're
Right,
loosely gravitationally bound against that backdrop.
right.
M24 is up in that area too, is it not?
M24 is more by Sagittarius, I think.
Yeah, it's right above the teapot spout.
Yeah.
Yeah. So this is NGC 6996, and it's a little more obvious that it's a cluster. It's actually this grouping of stars up here.
Huh.
So,
God, there's a lot of stars in these
And
pictures.
and this was, yeah, this is a region very rich in stars. And that's what the glow of the Milky Way was discovered to be when people started using bigger telescopes. They resolved it pretty much into stars. And this is a third open cluster up there. It's a good amateur object, NBC 6997. So, and you can see a lot of the star clouds here that are behind it. And then dark lanes. This is nebulosity that is not being illuminated or emitting its own light. It's not excited by a star nearby, but it does block starlight from behind. These are not holes in the Milky Way. These are dark nebula.
Gas clouds.
Mhm.
gas and molecular clouds.
Okay.
And some of them are organic molecules like methane.
When you say molecular, that means dust.
That means more than one atom hooked together to give it a new identity, like water, for example, hydrogen and oxygen.
And
Because
The water
once you can sort of see it as individual particles, then you call it dust.
Yeah,
okay, the dust out there is not like the dust under our couch, is it?
it can
That's
be, as
similar.
long as there's no dog or cat hairs in it.
Yeah.
When did I lose control here? Okay.
Okay, this is another region of the sky that's easy to get to. Now, this is 4 in the morning. It's for all the morning freaks. Here is Polaris. In the south, from Australia, they don't have a pole star like we do. So here's
Not
the
a bright one anyway.
Yeah, if you go down in magnitude, you'll find something.
Yeah.
So here you take from Polaris, you go right through one arm of the W of Cassiopeia. You go right through there and you end up at Merak. Now, Merak is halfway between M31 and M33. So it's an excellent star hop to find these two galaxies. You can see each of these by naked eye in a very dark sky, which we don't usually have here. So you have to use these star hops and go certain distances that you know from bright stars.
Huh.
And this is
The lower one, the
picture.
lower one is the lower of those two galaxies is not one of the orbiting.
There's a galaxy there and there.
Oh,
and
it is.
And
Okay.
they're galaxies that orbit around it. This is this is M20,
110.
110's there.
that's
Yeah,
it,
110.
110.
Took a while for
This
old
is
man Mills.
M31.
Okay.
Mhm.
And the little one is M32.
Okay.
Andromeda is 2.5 million light years away, but it'll reach us in many, many more light years after that, right? Is how
Like
far?
4 billion.
Yeah.
Oh, okay.
Okay. So now you can see the outer disk here. This is one of the most popular amateur things to photograph or look at. It's got a lot of structure that you can see readily. It's got its dark nebulas in here that are not missing stars. They're dust. That's probably going to collapse into clusters of stars or suns with planets. But you can notice that the outer disk here has a plane and the inner disk has a plane that's tilted. So the inner disk has this axis, the outer disk has this axis. So it's a bent, I guess you can't see me on there, but it's a bent disk. And our Milky Way has a similar bent disk, tipped down on one end and up on the other end.
Potato chip.
Yeah, it's a Pringle galaxy.
Yeah.
I'm sorry, this is Andromeda we're looking at?
This
Yes.
is the Great
Okay.
Nebula in Andromeda.
Okay, so somewhere in that picture is that incredible variable Cepheid that Hubble found and launched us into the Hubble
Up in this area somewhere.
constant. Yeah, right. Interesting. Wow. There's a bunch of them in that galaxy, aren't there?
Yeah.
A bunch of them in our galaxy too.
Okay, this is
Fascinating.
11 o'clock at night. And this is marking the 4th of July galaxy, which is NGC, the fireworks galaxy, which is NGC 6946.
Ah,
And it's getting it's technically in Cygnus. See the Cygnus, it's been gerrymandered into a border here to include the galaxy. And the galaxy looks like this
Overexposed.
from the Hubble. And it has 2 supernova marked on here from 2004 and 2017. The reason it's called the fireworks galaxy is because it has the largest number of supernova observed in it.
Oh, interesting.
It's busy.
Yeah, it has 10 supernovas since 1917.
Well,
The
those two don't look
2017
very
one
bright.
Well, they dimmed down. They're only bright for a couple of months.
Is that right? Hmm.
Unless you're looking farther back in the universe. You know how we were talking earlier about how, well, with Tom, I think it was before we started recording, how the farther away you're looking at something, because of the expansion of the universe, you get this cosmological redshift, but you also get a time shift. And so if you look at supernovae at really distant galaxies, they last, you know, 5 to, in the case of that galaxy Tom was talking about, it would last 15 times longer than they do here.
Is that right?
Yeah.
And they're different from these regular nebulae explosions that we're going to be talking about soon, right?
Well, they're different from novas, which is what we're going to talk about in T. Coronae Borealis.
Oh, I see. Okay. Novas are regular events. Okay.
No, not necessarily, but some are recurrent.
Excuse me a
Really?
second. Keep chatting. I'll be right back.
Okay. Some are recurrent, where the white dwarf doesn't get destroyed in the explosion, and that's what we're going to see for T. Coronae Borealis. So,
Okay.
so as
So
they
you,
continue feeding, they can repeat, and this one seems to repeat every 70 years, and we're expecting it to happen any minute now. But it
well,
doesn't destroy the white dwarf, so that's why it can be recurrent. But then
okay.
there are novas where you know it's irregular and weird. It just depends how it's feeding.
Well, have you guys got plans to zero in on it, say in September or later this year? If it
But when it
decides,
happens, yeah,
but you got to be told, or can you?
yeah, it'll suddenly brighten up to be naked eye visible, and then you know bulletins will go out and everybody will look at it. It lasts at its brightest, I think, only about 12 hours. And after that, it'll still be naked eye visible, but it'll be gradually dimming down.
But it's a white dwarf sucking something off of a red companion, and then that somehow overloads the dwarf and it blows up. Is that how that
Yeah.
works?
Yeah, it accumulates hydrogen on its surface in a layer, and when the pressure and temperatures reach the right level, it detonates like a
And
hydrogen bomb.
there's someone, I think it was JPL, that they call out that if you're looking up there and you see it,
Let them know.
that let them know, and you might be the first guy to see it. So
Yeah,
I
it's the
think
AAVSO, the American Amateur
okay.
Amateur, variable star observers.
Okay. Have any of you ever caught one on film or saw one in your instruments?
I've seen a nova before, but it wasn't a recurrent nova.
Okay.
Well, actually, it might have been. It might have been the one that went off in 1917 in Cygnus and then came back again.
Got to tell you, this picture you put up, Mr. President, we can't even see the galaxy, but not only does
Yeah.
Hubble see the galaxy, it sees two separate supernovas or
No,
explosions.
this is the galaxy we were just looking at. But
Yeah.
this is a wide field view. And this is a bonus. If you find this galaxy, then right next to it is this beautiful open cluster.
Wow.
So I took a picture of a supernova in M51, and by accident, I was just testing a camera, and I took a picture on my birthday about 15 years ago, and then I saw that there was a publication in one of the magazines of this galaxy with the supernova in it, and I said, wait, I took a picture about that time. So I went back and looked at the picture, and I had caught it. If I had been on my toes, I would have been the person that discovered it.
Oh,
Well, as far as we're concerned, you are the discoverer, Mr. President.
I'm just too by nature lazy. Now
Here we-
we're looking at the realm of recurrent nebulas, recurrent novas.
Ah,
This is a white dwarf star, and it's white because it's hot, but it's got no fusion going on. It's just cooling down from when it had a life. And this is a red giant star that these two are connected together gravitationally, and they're close enough that the white dwarf is sucking atmosphere and hydrogen, unburned hydrogen, off onto the white dwarf, and it's accumulating on the surface of the white dwarf. Now, this is where it is. T Corona Borealis. There's Corona Borealis, or Corona Borealis, and it's near Bootis and Arcturus. So it's an easy find. You can find this in the sky. And right off this star is where this is. When it goes, as that hydrogen accumulates on the white dwarf, eventually it gets piled up high enough that it gravitationally heats up from the white dwarf, and then it starts it has one fusion event. All the hydrogen has what am I looking for? An explosion. So that you won't get much notice of it because it happens quickly and it's gone. So T Corona Borealis, this is its brightness from 1944 to 1946. And right here, it went off. One was caught on the way up. And then once it was up, someone said, hey, and then everybody started watching it and measuring as it went down. So, but the performance of it for that eruption, it has a level of activity, and then it has a pre-eruption dip, and then it goes up. So that's what they're looking for. Here's currently that star, and it's going along like this because it is a variable star too, but this is the resolution here. Our photometry's gotten much better since the 40s. And so we actually can see the variability of the star, and probably just due to it orbiting, but maybe not. But there's the dip that has happened. And from the behavior in 1947 to now, they're predicting that this star will go nova, not supernova, but nova, late this summer. So this is a variable observatory or variable star observers chart. This is T Corona Borealis, or the blaze star down here. And these are the magnitudes of comparison stars with the decimal point missing. So this is 5, magnitude 5, 4.2, 4.6. And the trick with the naked eye is to, and you'll be looking at that every night, but if you're looking for this, the trick is to compare the brightness of this with the brightness here and notice any changes. And that's how variable stars used to be measured for brightness. And all stars were, once you had a scheme set up, all stars were estimated visually. Now our cameras can do an excellent job, but the camera takes time, and your amateurs are just going to look at it quickly or visually each night.
And it's when it goes off, it'll get about as bright as Alphecca that you see there. It's also called Gemma.
Yeah, right there.
Clarification question, gentlemen. When a star ends its life, that's called, when it explodes, it ends up a black hole or a white dwarf. That's supernova?
No supernova for a white dwarf, Ron. That's what you get when you get a planetary nebula and the core of the star just contracts. So that's what our star will do.
Okay, I'm talking about the end of a star. What
Of a massive star.
Yeah, what is that called?
That's a type 2 supernova, a core collapse supernova. But a white dwarf can also end its life when it siphons off enough material, or it collides with another white dwarf star, and then that's a type 1 supernova.
But my understanding, white dwarfs were created when they did have a star die and it exploded.
Yes.
And
no, it doesn't explode. It doesn't explode. That's when a star like our sun finishes its nucleosynthesis, which basically ends with like oxygen and carbon, and it just poofs off its outer layers. There's a bit where it starts fusing helium called a helium flash that kind of poofs off most of the outer layers. And then the core collapses to form a white dwarf, and that causes the stuff around it to glow in a planetary nebula. And the white dwarf, if it's isolated and all by itself, like ours is, will basically last for trillions of years and just become a black dwarf, which will just be like a charcoal briquette in the sky.
Right.
Yeah, M57 is that way right now. It's the white dwarf in the middle and the planetary nebula around it.
Yeah, the ring nebula. Yep.
Right.
So what Chuck is describing is a white dwarf that's all by itself. This white dwarf is not all by itself. It's stealing fresh hydrogen, and eventually that will blow up on the surface, but just in a flash.
Huh. Where does
that happens enough, you might build up enough material on the white dwarf that eventually it'll reach that Chandrasekhar limit and blow up in a type 1 supernova.
And does all that debris stay out there as part of the dust and gas cloud? Is that, or does it?
It expands around it in a nebula.
Okay, that's where we get our nebulas in.
Yeah.
Some of them.
Interesting. Okay. That's the center of the Milky Way we're looking at, isn't it?
Yeah.
Yes.
You can see the pipe nebula there. The
Yeah,
dark thing that looks like a pipe right above the center.
we definitely are at
Oh,
an
this is
angle.
just a backup thing.
Yeah.
We already covered that. But and I should have made a chart of this, but if you do see the nova go off, there's a place you go to an AAVSO site. You may have covered this while I was
Not really, no.
okay. So you can report it and be the first to report it. And it will, if they confirm it, then it will be with your discovery name, it will go out on an astronomer's telegram and distribute it around the planet. So a lot of dedicated amateurs are going to be spending every clear night hoping to be the one that is the first to see the T Corona Borealis flash.
Well, gentlemen, I should know this. Why does Corona Borealis share the Borealis name with the Aurora Borealis?
It means northern in Latin.
northern. Is that what it? Okay.
Because
And
there's the Corona Australis,
Australis is the southern version.
right below Sagittarius.
Have they been having the super lights that we've had up here on the south? You think?
Yep.
Have they? Okay.
But they're not called Aurora Borealis.
I know that, but
Right.
can they usually see their Borealis or whatever it's called, their auroras?
When
Yeah,
the
They
sun
see
is
them
active.
in Australia.
Yeah. New Zealand, Australia.
Yeah.
Can they
Tasmania.
normally see them? Or did they see them now because of what we saw?
Oh, they normally see them just like the northern parts of
Yeah.
North America see them.
Really? It's a hot country.
And Borealis it means north in Latin.
Yeah.
Okay.
And Australis means south.
Okay.
But the Corona Borealis is a constellation. What's it pictured as?
Crown.
Corona.
Crown.
Like a crown.
Oh, a crown. That's what we're looking at here?
Yeah.
Right.
I think it's Ariadne's
Corona-
crown.
Is
The
there
crown is crown.
is there a Corona Australis?
Yes, just below Sagittarius.
Yeah.
Not in the southern sky, southern
It
hemisphere?
is. It's just
Yep.
below Sagittarius.
Yeah, we can see it
Oh.
easily.
Well, Sagittarius is the middle, isn't it? That's where the big
It's the
black
core
hole.
of the galaxy, but it's in the southern sky for us.
Oh, okay. What's Serpens caput?
The head of the snake.
Of
Caput is
course.
head in Latin.
Is caput know what I think it means? What I think it means?
It means head.
It means head in Latin.
In
Really?
German, it means broken.
Well, yeah. I mean, capital, Ron, capital.
Yeah.
That comes
Wow.
from head too, you know.
Fascinating stuff. Have
So
we run
Ron,
the
there's a Serpens cauda too.
Yeah,
Right.
there's a tail.
Yeah.
Tail.
Oh,
Wow.
wow.
Nowadays, a lot of planetarium programs treat it as one constellation, Serpens, but it used to be, or officially it's two.
Well, I don't think there's a single animal of any note that's missing from the night sky, is there? Except a rhinoceros. We don't have one of
No
those.
mosquito.
No.
Platypus.
Yeah.
Everything else is
I bet the Aborigines in Australia have a platypus constellation, though.
Yeah, they
they
probably
probably
do.
do, yeah. Have we run out of time, Mr. President? Are we?
Almost.
2 minutes.
So let me tell you that I give a talk at the museum on Sunday, which is a lot of fun. One of them's on IR technology, infrared technology, and the James Webb Space Telescope. And if there's a big audience, I asked the audience that infrared is out of the visible band that we humans cannot see infrared. But there's two animals on Earth that can see in the infrared.
Mhm.
And I ask, do you know what the two animals are? And usually the parents don't, but a lot of kids do.
Mhm.
So do you know
Rattlesnakes,
what-
pit vipers.
Yeah, pit viper, rattlesnakes, that's one. And the other one is mosquitoes.
You're kidding.
They can
I think-
see people glow in long wavelength IR, people glow like light bulbs. And those
Yeah, they were after us Friday night like gangbusters.
yeah.
And they can see at night.
Oh,
They
yeah.
can see you at night. They don't see anything else, but they don't care.
See anything hot.
Now, Jerry, did they give you a little infrared camera so that you can demonstrate some of
No.
that?
No.
Because in the observatory on Sunday, they have an infrared camera set up. And so you can see which parts of you are hot and which parts are cold. But they also have a plastic bag there, a plastic trash bag, a black bag,
Yeah.
so that you can show that it's opaque to visible. But if you put it over your hand and stick it in front of the camera, you can see your hand through
Yeah,
the
it's
trash bag.
transparent to IR.
Yeah.
We walked over to the observatory thinking you might be there to say hi, but it was too early. So
Okay. Yeah, I don't get there till
the guy
2.
we saw the camera and the setup and stuff.
Did you have a pretty good crowd, Mr. President?
They have it set up for about 36 people in the audience. We generally have groups in the 20s.
Were you in the Fleischmann or Farrand?
No, that courtyard room with all the James
okay.
Webb pictures.
That's yeah, 30 would be, yeah, 36 would be a good crowd in there. You're right.
The observatory had 197 people yesterday.
Wow. Go ahead, brag.
Yeah.
Well, we're gonna
Is the telescope fixed now, Chuck? No.
Yeah. It was tracking the sun when we started, but then it just went into this random mode where it jumped around the sky a little bit. And after that, we had to, keep hitting the buttons to track the sun.
Yeah, we did. It did that the day Tom and I were there.
If we have anybody listening and watching the program that's not a member yet, if you join the club, it'll probably be less money than you get a all-you-can-eat Golden Corral buffet dinner by coming this Friday night, because that's the only way you're going to get in. 5 o'clock, actually, right? For the big potluck.
5 to
Show
7.
food to
Yeah.
get in.
All right, looking forward to it, gentlemen. You did good. I thank you. Take care of yourselves and your wives, and we'll see you for all kinds of things. 4th of July, and then 5th of July, and then next Tuesday, and we'll join you again next Monday morning for the Astro Hour.
Thanks, Ron. Thanks, Jerry.
Thanks,
All right,
everybody.
thank you, everybody.
Monday will be
Appreciate it.
my 83rd birthday.
Bye.
Oh.